I have a presentation for us. So I'll just slide through the presentation as we go, and I'll try to just talk about it. So what is sound? Sound is vibration that moves through a medium such as air, water, solid material, and can be perceived by the ears. And I'm going to give an illustration, okay? So we talked about object vibration and being perceived by ears. So for example, so I'm striking on the snare drum, all right? So basically, if you notice, there's a there's a sound that once I hit this, yeah, there's a vibration, right? And that vibration creates audio, right? Which in return we're able to perceive in our ears, right? Another typical example can be this, right? Here's an object, all right? So if I drop this on the floor, right, the moment it hit the floor, you hear sound, all right? So basically, that is sound, all right? Okay, clear? Is that clear? Oh, let me also give another example. So I want us to put our hand on our throat, right? Okay, and say hi. What do you feel? Vibration, right? There's a movement. Have you guys also noticed, like in your speakers, yeah, the drivers, right? When you play music, you see the driver going back, front, and all of that. Yeah, exactly. So, yeah. All right. So let's move to the next slide. All right, so let's talk about the inside world of a sound engineer. So the first thing I want to talk about is recording. So basically, recording, capturing audio from various sources with clarity and precision. The audio engineer select the right equipment and technique to produce clean and high quality audio. So now I'm talking to us, and basically what we're doing here is we are reinforcing my voice, all right? So reinforcing means we're amplifying my voice, okay? And in order to amplify my voice, we need a microphone, right? So right now, I am talking to you like this. If I move the mic away from my mouth, right? Can you hear me? Can you guys hear me? You can hear me, but not as loud as this, right? Exactly. So the work of an audio engineer is to amplify sound from different sources, yeah, with clarity in mind. Okay, so meaning that in order for you to amplify sound, you need to use the right microphone and the right miking techniques, right? So if you move this mic off axis from my mouth, your decibel level reduces. Means that the audio that you hear reduces, right? So we're going to illustrate that again, all right? So I'm going to move the microphone off my mouth and talk to you guys. Obviously, you guys cannot hear me, right, as much as this. So your miking technique is very, very important. And it's also very important for you in order to give your clients a listening experience. You, as the audio engineer, need to be able to identify what you're trying to capture, what information you're trying to capture. So right now, we're here for a training, and the information we're trying to capture right now is me talking to everybody, right? So it means that there have to be a microphone pointed in my mouth, which is the source. That is where the sound is coming from, right? Awesome. Good, 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 good. Okay. I hope I'm not doing bad. Anyway, so the second pointer is mixing. So mixing is the balancing and blending of multiple audio volumes. Yeah, there's so many things. Okay, so balance and blending multiple audio tracks and adjusting levels, panning effect, and all of that. Now, I don't know if any of you have seen a mixer. What it looks like. Maybe yes, maybe no. Oh, you have. All right, cool. Okay, so in the world of sound, there's always a mixer. Basically, what the mixer does is it takes all the information. So all the mics. So for example, I'm speaking to you with a mic. Yeah, this is a wireless mic. There is a transmitter somewhere. So basically, the transmitter receive from the receiver. So this is the transmitter. Sorry, there's a receiver somewhere. So the receiver receive information from the transmitter, which is this. So when I talk to this mic, the receiver picks the information this mic is sending to the receiver, and the receiver sends that audio to the mixer. All right. So basically, that audio goes to the mixer. So what the mixer does is it mixes the different levels, yeah, of the information that you get. Like, let me use another example. For some of you that have worked in a recording studio, right? So when you go to a studio, you see a microphone and you see like a what do you call it? What's it called now? Like a pad, basically to isolate the background noise from the microphone for better clarity. Now, sometimes you see a keyboard player, a bassist, and a guitarist, everyone playing, to that track, depending on what you're trying to do with the track. So the instrument goes into a mixer, right? And in that mixer, there's a DAW. The DAW is the software. You see a computer and a DAW, right? So once you play your keyboard, you can see the keyboard signal on your monitor screen. You can see the bass signal on your monitor screen. You can see the vocalist. Let's say I'm the singer, I'm the rapper or a singer, and as I'm singing, you see my signal on the DAW, right? So basically what that DAW does, serves as a mixer, right? So in that DAW, you can mix the levels. So you don't want, like for your music that you listen to, for example, let's use Ashake, for example, right? Now, it's going to sound weird, right? If you're listening to Ashake and you can't hear his vocals, right? You want to hear his vocals. You don't want to hear the instrumentation over his vocals, right? So basically, that is what a mixer does. So the mixer helps blend all the various instruments. So you're able to adjust the various levels of the instrument and give the consumer a good experience. So you don't want the drums louder than the vocals. You don't want the bass louder than the drums. You don't want the bass louder than the vocals and all of that. The vocals is always sitting on top of the instrument. So basically, that's what the mixer does. All right. So editing is refining the recorded audio and removing noise, fixing timing issues, and polishing the overall sound for a professional standard. So the last section usually is editing. Don't worry, I can give you guys this. We'll give you guys this PowerPoint or this slide after. But yeah, so editing is the last stages of sound engineering. So basically, if there are noise maybe in the instrument, in the guitar line or in the bass line, at that editing stage, that is where you clean up all of those things. You clean it up, you polish it, you make it sound good, and you now send it out for consumption. So if you notice, there are some recording you listen to, and for example, when you listen to maybe a Asha music, and you listen to I don't want to call names, but you listen to some Fuji music, you realize that the Asha music is cleaner, like it sounds better than the Fuji music, because there are stages and process to these things. And once these stages from recording, capturing, mixing, volume control, and all of that, if all of these processes are not done properly, the end result matters. So if you listen to some of those Fuji music, you just realize that they are very painful to the ears, and you don't know why. But why is it different from a Asha music, or why is it different from, I don't want to call names, you get. So these are some of the processes that people tend to, undermine, when producing music or mixing a live show. Oh, let me just also use another typical example. So you go to Us on the Rock. Who has been to Us on the Rock? Okay, anyway, I'm not a Us on the Rock member, but I'm just, So you go to Us on the Rock and you listen to the sound, and it sounds beautiful, right? Then you now go to maybe Assemblies of God, or you go to one church, and the sound is just annoying. Like you can't properly perceive, the messages. Like, you're not hearing, like there's no clarity. Like right now, we're using a Bluetooth headphone, and the reason for using that is to get us engaged with my conversation. So as I'm talking to you, you can hear me nice, audible, clear, and all of that. So you're not hearing all the noise from the room, the acoustic noise, the AC noise. You're not hearing that my brother there, talking to somebody. So these are some of the approaches that, an audio engineer do when you're making decision, for a given space. All right. So let's move on. All right. So next slide is microphone. All right. So there are three common microphones, right, commonly used, all right? So we have the dynamic microphones, okay? So a dynamic microphone uses a diaphragm attached to the coil within a magnetic field to convert sound waves into electrical waves, okay? So basically, I have a dynamic microphone here, right? These are commonly used everywhere. This is a SM58 microphone, right? So basically, these are transducers that convert analog signal to electrical signal, right? So here is that, okay. The next microphone would be a condenser mic, I think, on my slide. Let's see. Yes. So condenser microphone is a type of microphone that uses a capacitor-based technology to convert sound into an electrical energy. Now, with a condenser microphone, right, we need to apply a 48-volt phantom DC power, all right, for it to work. Now, in every mixer, there's always a 48-volt phantom power, either on each channel. So when I say channel, I mean the size of the mixer. Mixer comes in different format. They comes in 8, 16, 32, 48, 64. All right. And they basically do the same thing. Whether it is analog, whether it is digital, they both take signal and send out signal. So do not be intimidated by any look of any mixer. You understand? Whether the mixer is like big from here to that place, it's the same thing, same formula. Takes in signal and it sends out signal. That's what they both do. Okay, so 48 volts phantom power. For smaller mixers, it has a general phantom power on the mixer. So you just press it on, and any condenser mic that get plugged to that mixer get powered on. But if you don't on that 48 volts, it's not going to work, okay? For some bigger mixer, you see that the individual channels do have a phantom power. So it gives you the option to activate the phantom power or deactivate the phantom power, depending on the mic choice. So if you're using a dynamic mic, you don't need to put on a phantom power. And even if you put on a phantom power for a dynamic mic, it doesn't destroy the mic. All right, it doesn't. Where phantom power destroy anything is on your computer. So if you plug your computer straight into a channel and you plug a phantom power on that channel, it destroys the headphone ports of your computer, and you just realize that you can't. Your computer, your computer sound card or audio port isn't working. Okay, so condenser mic requires phantom power. All right, to work. Okay. An example of a condenser mic is this. All right. So usually, most of them are usually very tiny. Yeah. So a condenser mic are usually used for things like your drums overhead. You guys know overhead, your cymbals, your drum cymbals. Sorry, I don't have pictures here. All right. But you know your cymbals. So in most cases, you see a mic on a stand like this, capturing the ambience of the drums, not necessarily. So a lot of people think that the mic is meant to capture the cymbals, not the cymbals. It's meant to capture the cymbals as well as the general ambience of the drums. Okay. All right, cool. So that's what your condenser mic, and also too for some studio, you see some of the microphones are condenser. You know, they use that for some studio. All right. Next slide is your ribbon microphone. So ribbon microphones a type of dynamic microphone that has thin strip or metal suspended magnetic field. So basically, your ribbon microphone are usually used for electric guitar amp. So I don't know. Have you guys seen like a guitar amp? So your guitar amp usually are those. You see those on stage or in the studio. You see a guitar player playing in front of a amplifier, basically, right? So what that amp does is enable the guitar player to, it's like a pre-amplification. So it helps the guitar player to hear himself off. It's like a monitor. So once I strike a note, I can hear myself before that sends out to the mixer. So basically, that's what the guitar amplifier is. Yeah. So usually, I don't know if you look closely. Sometimes you see that there's a miking technique for those guitar amp. They use microphones for those to mic the cabinet. So the microphone is usually placed in front of the driver. So you find, so sometimes you see there are 12. If you look closely inside the guitar amp, you see it's either a 12 driver, a 12-inch driver, right? So if you need to capture that guitar amp, you need to position the mic just in the middle section of it, not off, because if you do it off, the same thing that happened to my vocal like this, that's what will happen. So if you want to capture the direct source from that guitar amp, you have to place the microphone in the center of that driver, so it picks directly from the source. All right. So that's just a miking technique for that. Okay. All right. Cool. So yeah. So guitar amp, bass amp, trumpet, saxophones, drums overhead. Some people use, ribbon mic for drums overhead, as well too. So it's very, very important that when you're miking your instrument, yeah, your choice of mic matters. All right. If you use a dynamic mic for your drums, I'm not saying it's not going to work, but it's not going to give you that sound, the sound that you want to hear, the natural sound. So you don't want to. Now, if you listen to this, you can hear how it sounds. But if you use a wrong miking technique and a wrong microphone, you would not hear the sound. It will probably sound a bit boxy or a bit different. So you want to capture this sound. You understand? So your miking technique, your choice of mic is important for the instrument that you are trying to capture. You understand? Okay? So you're not going to use a wireless mic for this. You understand? Because these are for voices. All right? So let's go to the next slide. Okay, so polar patterns in audio. All right. So polar patterns basically is just it's how the microphone captures, how it picks the source. You understand? So we have omnidirectional, supercardiode, cardiode, and bidirectional. All right. So basically, your omnidirectional captures sound equally from all direction effectively. All right. So like I said earlier, your choice of microphone, yeah, is very, very important when you're amplifying a signal, right? Now, this mic is commonly used for choirs. All right. So if you have maybe you have 20 choirs, right? And you're dividing them in parts. So let's say you do alto, tenor, soprano, all right? And the budget does not permit. These days, our Gen Zs now, everybody wants to use wireless mic. So if you have 20 choirs, the promoter must provide 20 wireless mic. But back in the days, what they do is they use a omnidirectional mic for the choir. So if you're splitting the choir into 3 parts, you see the omnidirectional mic in the middle of the choir. They form a C form, right? And everybody sing. So because the mic is omnidirectional, it picks the surrounding, the noise and the surrounding, right? So you're not going to use a mic like this to capture an entire choir. You get what I mean? So your mic choice and selection is very, very important for the application. All right. So that's what your omnidirectional mic does. All right. Your supercardiode microphone focuses on sound directly in front, with some rare pickup. So this is more like a 180 degree. So it captures the sound here, right? And the sound just on the side. Basically, that's what this does. All right. So this you're going to tailor to an individual. You're not going to use this mic for a choir. All right. Is that clear? All right, cool. Cardiode mic. The mostly used microphone in the entertainment industry, which is this SM58. You never go wrong with the SM58. So SM58 you use for an individual like myself. I'm talking, I'm singing. It's the pickup pattern is in the front, like rare. It takes rare noise from the back. It picks in the front. So that's what your cardiode mic does. All right. Okay. Um, the next is a bi-directional microphone. So it captures sound from the front and the rear rejecting side. So basically, as you can see, this is a studio, right? She's singing, right? It's capturing the mic from the front, right? And also at the rear, you understand? And this side, on the side there, it rejects sound on the side. So this microphone, you want to use it for in a studio. Mostly is used in a studio, right? To capture the source just from the front. Yeah. So basically, that's your bi-directional pattern. All right. Cool. Let's talk about cables. All right. For example, your keyboard, right? Is everybody familiar with keyboard? Okay, all right. So you need to amplify your keyboard, right? That signal from your keyboard needs to go into an amplifier that amplifies it for the ears to perceive, right? So in order for you to amplify the keyboard, you need a jack cable, which is your TRS. We commonly call it jack cable, by the way, but it's professional. It's called TRS, tip ring sleeve. That's the meaning of TRS. So this is what the cable looks like. So this goes speak-on cables, all right? So speak-on cables are your speaker cables, all right? So speak-on cables are a type of professional audio cables that connect amplifiers to loudspeakers, right? Let's leave it there, but you have all of that. So for your speakers, right, you need a speaker cable from your amplifier to your speakers. So this is what your speaker cables look like as it is on that picture. Now, if you look at this speaker, all right, you'll see that's a speaker cable, okay? So that's connect from your amplifier into this guy in order to send signal to this guy. So that's basically what your speaker cable does, all right? So it's commonly used for your loudspeakers, from your amplifiers to your loudspeakers. All right. Okay, so we are talking about Sound 101 basic, the foundation of sound, right? A lot of us, especially our generation right now, yeah. One of the things that make us fail a lot is because we do not learn from the foundation. We are very carried away with what we see on Instagram, all right? So you see a big concert and you see a mixing engineer behind the console and you just feel it's cool. Like, I like what this guy is doing. So I want to equally just find myself behind the mixer, just pushing faders and all of those things, you understand? Without your basic knowledge, which are all of these. So before the guy can, before the mixing engineer can be able to mix on his mixer, right? There's so many works that have come into place. You understand? Like, for example, how is he getting this microphone? What is he mixing? How does he get the keyboard signal? You understand? All of those things. Somebody has done that work. You understand? So it's very, very important that we go back to the grassroots. So, for example, these are these are female connectors and these are male connectors, right? In these connectors, right, there are pins in these connectors, right? Now you see the XLR cable like I showed you earlier. Now in the connector you have 1, 2, and 3, right? Now a cable is connected to this. Now, some of the questions that you should ask yourself is, how did they get to manufacture, how did they get to solder these cables into the connectors? You understand? What does this, like, you should be interested, like, open the connector and see what's happening inside. So what does 1, 2, 3 means? You understand? Oh, I see that the cable has different colors, right? This has a color, this has a color. How do they connect? All of those things. So as this diagram is, it has shown you, right? So you see, when you open the connectors, you see 1, 2, 3, right? So your 1 means your shade, right? Your 2 is your positive, and your 3 is your negative, all right? The same thing applies here as well. So your 1 is your shade, your 2 is your positive, and your 3 is your negative, right? So it means that when you're soldering, right? You guys understand the word soldering, right? When you're soldering a microphone cable, right? It's important for you to take into consideration the connectors port. How do you want to solder? So like this diagram has given to you on, for most of the microphone cable, you see that there are color codes on the cables. There are always 3, right? So this is red, white, and blue, right? Red, white, and blue. So your white goes to your shade, which is, let me use the common term, neutral, right? Then your red goes to your positive, right? And your blue goes to your negative, right? So 1, 2, 3. The same thing the same thing is applicable. You apply here as well too. So your 1 to your white, your 2 to your red, and your 3 to your blue. Now, if you swap the cable around, right, what will happen is you start to hear like a buzz noise. Like, for example, this AC, it sounds like and you're wondering what's happening. Now, some of the cause of that is because the cable isn't soldered properly. All right, it's either it's been swapped the other way. It's just like electricity. If you swap the polarity, it sparks. Like you get a spark, and the end result is damaging your appliances and all of that. So basically, that protocol is applicable to audio when you're soldering cables and all of those things. All right? Does that make sense? It does. All right, cool. Okay, next slide is your jack, okay? Like I said, it's a tip ring sleeve, right? Basically, right, when you see your jack, so your jack is basically a unbalanced signal, basically, right? So as you can see, this is a stereo jack for your headphones. Okay, I think I have one here. Hold on. Yeah. So here's a typical example. All right. Now, when you see this, like I said, like you want to know how these connectors are being soldered, what it does, why do we call them, jack and all of that, So as you can see, right, it's telling you this is your left audio, this is your right, and this is your ground. This is a stereo jack. So when you see left and right, it means stereo, like your left hand and your right hand. It's a stereo signal. So basically, that is what your jack does. So when you're soldering your jack, as you can see on the diagram, right? So you can see that this green goes to your left, the red goes to your right, and the blue goes to your ground. Or the green goes to your ground. All right. So the way you solder it here is the same way you solder the other end. You have to observe the color coding. All right. Like I said, so your green goes to your ground, your red goes to your right, and your blue goes to your left. All right. Okay. All right. So let's move on. The next is your speaker, all right, which is your speaker cable, all right? So same thing applicable to your speaker cable. So when you open up the connectors the speaker cable, you open the connector, you will see 1, 2, 3, 4, all right? So in it, you have -1, +1, -2, +2, all right? So as you can see, these are your cables with different colors, all right? So they are usually color coding for your cables. Usually the lighter cable are always on the minus, and the deeper, which is like red, are on your plus. So for example, if you choose maybe yellow and red, right, as your +1, -1, it means on the other end, you're going to choose yellow and red as +1, -1. Because if you swap it the other way, no signal will be sent to your speaker. So it's important that your wiring, when you're connecting, when you're wiring your connector, you observe the wiring procedures, which is +1, +1, -1, +2, -2 on both sides of the cables. All right. Cool. DI box. All right. Have you guys seen this anyway? DI box. All right. They are called direct injection box. I have one. Yeah. So basically, this helps convert unbalanced signal to a balanced signal. So for example, I made an example earlier with your keyboard. On most cases in the church, when you go to your church or you go to your studio, right? Sorry guys, let me just do this. So if you are a guitar player or a keyboard player, right? Let's use a guitar for an example. Now you need to amplify your guitar into a mixer. So basically what you do is this goes into your pickup point on your guitar, right? Just imagine my hand is the guitar. I don't have a physical guitar here, right? So you see a pickup like a hole where this connect into is the female, why this is the male. So the male goes into the female, right? Then the other end of this goes into your DI box. Now, there are usually two types. There's a mono and there's a stereo DI box. So a mono DI box means one channel. A stereo DI box means two channels, all right? Please, it's very important. So, for example, this is a stereo DI box. So if you can see, it shows left and right, all right, inputs. The output shows right and left, okay? So it means that if you plug these to your left, right, your output will come out of your left. All right. If you put your cable on your right, this signal that goes into your left would not be sent out because it's meant to be on your left. So, hence the reason why it's called a stereo DI box. So you have a stereo and you have a mono DI box, and they help convert unbalanced signal to a balanced signal. Okay. So for example, like I said, guitar, keyboards, and any other instruments. All right. Signal flow. So sound source, input, and preamp. Okay, so sound source, so signal flow basic, sound source, input, preamp. Sound source, the initial signal is produced from a musical instrument or voice. So what is your sound source? Your sound source is where the sound is coming from, right? So like I earlier said, signal flow, it's coming out of my mouth. And in order to amplify the sound coming out of my mouth, you need a microphone, right? Exactly. I just gave a typical example. You have a guitar player or a keyboard player. You need to amplify that. You use a jack cable or a TRS cable from the output into your DI box. DI box sends it out to your mixer. Like I always said, there's a rule to sound, right? Once you can understand that in sound, it works like this: out to in, right? In to out. It's never out to out and in to in, right? You can work anywhere because most of what we do in sound is connection. And if you don't understand that principle, it will be very, very difficult, you understand, for you to even go out and be able to connect, a piece of equipment. So you have to understand that, the signal flow or the signal patch, for sound, it works as, out to in and in to out. You understand? So that would also give you an informed decision with your cable type. So this is a female XLR cable. That is a male XLR cable. The microphone is the source. It's taking the signal from my mouth to convert it into a mixer. So I need the female to go to my microphone, and that sends on the other part of the cable will be the male that goes into the female. So it's always a male to a female, not a male to male or female to female. All right. So that's the explanation of sound source. Okay. Now input device. So your input device can be your DI box. I just showed you guys. It can be your mixer. All right. Basically, like I said, your mixer blends various signal. You know, in your mixer, you can adjust levels. They are EQs. So basically, your EQ is it helps shaping the tone. So, for example, if you want, let me just do something. All right, let me do something. Unfortunately, we can't. I can't show you guys in practical, but I just want you guys to listen to something, right? So, I am on my mic. Okay. Yeah. Yeah. Hold on. Let me just see something. Okay. Good. All right. Yeah. Do you guys notice something? I sound a bit funny, right? Yeah. Okay. Cool. Yeah. Yeah. Now I sound good, right? I sound better. Okay. Basically. So that's what your EQ does. So if you look at, okay, let me use another example. For some of us, yeah, in your at home, you see you have a radio. In that radio, there's a section that shows that writes treble, mid, and bass, right? I don't know if you guys have played around with it. So when you take down the bass, what do you notice? Like the woo, like your kick, your bass, like it sounds very tiny, right? When you take it back up, it sounds heavy. Then on your mid, right? If you take your mid, just like what just happened now. So right now I'm going to take down the mid, all right? So there's no presence, all right? I'm taking it back, okay? Now the highs. Did you notice a difference with the highs? It sounds like very, very pitchy. That's the highs, all right? So if you haven't tried it in your house, right? Just your what do you call it, your radio, just watch out for it. It always have like a equalization, so low, mid, and highs. Play around with those things and hear the difference. All right, so yeah, that's that. Then preamp. So basically your preamp are your amplifier. As the word implies, preamp, it helps amplify whatever signal that goes into this. So in a studio, let me use a studio as an example, right? So you have your computer that has maybe Pro Tools, Cubase, or whatever the case is. You see an audio engineer mixing on Pro Tools, Cubase, and all of that. Now you see it has a sound card, right? A sound card connected to that. So that information passes through that sound card, and the sound card sends it out to the speaker for our ears to perceive. So basically, the preamp is your sound card. All right, your guitar amplifier that I referenced not too long, right? So you plug your guitar into your guitar amplifier. Basically, what that guitar amplifier does is it amplifies the guitar or your keyboard amplifier. If you plug your keyboard to that amplifier, your keyboard amplifier amplifies the keyboard. So it multiplies the wattage of that signal and makes it sound bigger. So basically, that's what it boosts. It boosts the signal to a usable level for processing. You understand? So that's what your amplifier. And anywhere you see amplifier or a pre-amplifier, basically it boosts the signal level. You understand? All right? Okay. We are going somewhere. All right. Is there any producers in the house? Anybody that produce music? No. Okay. Okay. Because I have, I'm looking for the best way to explain all of this. That's why I asked. Okay. Let's use a live stage. All right. Let's go outside the studio world. Let's use a live stage. Right. Now, the first thing is organize track, label, color codes, group track, vocals, instrument, drums for easy flow. Now, I want to talk about something, and it is very, very important, yeah? One of the things that you would always find in my backpack whenever I go to work, right, is a Sharpie, right? I always take a Sharpie anywhere I go. Another thing that you'll find in my bag is a PVC tape, all right? Now, the reason for this is so that for every connection that I do, I labeled that that connection or the cables. Like for example, now if you see on this, you see this is written keys. So it means that when you go on stage, right, you plug it to your keyboard. You have to be able to identify the cable so that, for example, say God forbid now something happens to you, you fall sick, right, and I'm taking over. When I go to the space, I should be able to identify quickly what is this cable for, right? You go to some setup and you see a bunch of technicians when they work, like there's no orderliness. Like the cables is just all over like spaghetti connection, no labeling. So there's an issue and you're trying to troubleshoot that issue. Now it's now difficult because you're not able to identify which is which. You understand? Which is the base cable, which is the keyboard cable, which is the microphone cable. So it's very, very important that as a technician, when you're working, and not only in the audio space, you understand, in any space. So for example, if you're connecting your computer, you understand, so you have your computer, you have maybe a printer, you have all of those things. It's important for you to label your cables because you connect from output to an input, you understand. And when you're trying to troubleshoot or you're trying to identify which is which, all you just need to do is to see, okay, this is my computer, that's my computer, you already know, and you take out the cable. So a lot of people, so it's very, very important that your workflow should be more organized, when you're working. And this is my best friend. This is my best friend. Like I have them in different colors. Sometimes I probably I don't label it. I just use color coding. So if I put green probably means keyboard. If I put red probably means bass guitar. You understand? So it's easy when there's a problem. I'm able to identify, you understand, through color coding. So essentially that's what this part is trying to say. So organize your track. So for example, on your door, there's no producer here. So for example, like I said, so my microphone cable, all I need to do is, I need to label. So I can label it as this is my female vocal, cable. This is my male vocal cable. This is that. So that when you're troubleshooting, it's easy for you to say, okay, this is that is that. So organization of your workflow is very, very important, okay? Now, gain staging, right? Gain staging means setting a proper input level to avoid clipping and maintain headroom. I'll give you guys an illustration. So a typical illustration is a traffic light, all right? Now, your traffic light is green, orange, and red, right? Yeah? Green. Okay, yellow. Okay, let's use yellow. I saw a reaction like yellow. All right, cool. So green, orange, and red, right? So when it's on green, it means good to go, right? When it's on yellow, it means caution, right? So is either go or stay, right? One of them. Then when it's on red, it means danger, right? All right, cool. The same